Welcome to Intralogistics Insiders, brought to you by Sinaos. Explore the latest trends, challenges, and innovations in intralogistics with industry experts.
Welcome to a new episode of Intralogistics Insiders. We have today Tony and Iván, in charge of robotics at Mercedes plant in Vitoria. Welcome to the show.
Thanks a lot.
Hello, thank you for inviting us.
So let's start from the beginning. So can you tell us a little bit about your background and how did you get involved in automation at Mercedes-Benz in Vitoria?
Okay, my name is Iván Caño. I'm responsible of robotics engineering in Vitoria factory. I've been working since 2002 with robots, so there are many years working with robotics. And I'm responsible of the introduction of new robots in the new lines and new standard that we are going to use. And I'm responsible as well and another issues related with the robot like tool changers or like pneumatic modules and that kind of stuff.
Yeah, my name is Antonio Real. I've been working for Mercedes for 14 years now. I started as a technician, line driver, some kind of master of all technician, doing the first breakdowns, the first assessments of the problems, and then I was for 5 years foreman of maintenance, all in body shop, and then for the last 3 years I've been the colleague from Iván in engineering as a robotics engineer, and I'm in charge of mainly the robots of final assembly and some technologies, new technologies for us, joining technologies in body shop, and yeah.
Awesome. Can you tell us a little bit about the story of Mercedes plant in Vitoria?
Well, probably Mercedes is one of the oldest factories in Vitoria.
Yeah.
So perhaps the other one is Michelin as well, but Mercedes is since I think that 1950 and it's more than 60 years in Vitoria. I mean, we started, which is very for me it's very funny. We started like Auto Union, which is Audi. Then we were a kind of, some years later, we were a joint venture as well between Mercedes, Volkswagen, and I don't know if Audi as well. Mm-hmm. And then since I don't know how many years ago, we are just only Mercedes. Mm-hmm. Okay, but I think that the last 30 years we are Mercedes.
Yeah,
I think so.
What vehicles are being produced at the site?
Currently, we are making the V-Class, which is like a car, more or less. I mean, it's a luxury car. And then we make as well a commercial car, which is called Vito, which is the name comes from our city name. And this is, we have several lengths, we have many, I mean, all the option or customer want or they need. I mean, so at the end, the options we have here are so many that it's crazy sometimes. I mean, the mix that we have manufactured.
Some say that we could produce single vehicles in the whole year with our production. So we didn't repeat any of them with all the options we have.
Yeah, all of them are completely different. I mean, it's completely custom vehicles, completely ad hoc vehicles. And you can...
We don't bulk produce. Yeah. Every single van we produce has already a customer that selected the options. So each one of them has already a name behind it.
Wow.
So at the end as well, it's a challenge not only for the production, but also for our suppliers, because we are working on just-in-time procedure. So you have to synchronize everything in order to get all the pieces at the time you need in a line, which is amazing as well.
For those that don't know what just-in-time is, can you explain it briefly?
Yeah, just-in-time is, I mean, we don't work with stocks normally, I mean, or minimal stocks. I mean, for example, if we need a wheel, we are not going to store this wheel in a kind of buffer or something like that close to the factory. We are going to remove from the truck and directly mount in the vehicle. So at the end, this is going to save money. I mean, it's a concept of saving money, and you are not having you are not going to need space, and you are going to save money as well.
Can you explain us in a very short way where does the name of Vito come from? But tell the full story because you didn't explain fully.
Yeah, well, which is Vito is from Vitoria, but it's something funny as well because when we try to use this name in USA, or Vito is called Metris.
Okay.
Because Vito is a copyright name in USA.
Okay.
Something was funny. I mean,
I thought it was coming from Vito Corleone.
Probably, but we couldn't use that. I mean, at the end, if you go to USA, the van is the same, but the name is Metris.
Okay. To what countries are the cars produced at Mercedes Vitoria sent to?
Worldwide. I think not to China.
To China because we have a specific factory in China.
Yeah, but when you see all the finished vehicles and you see the stamps to where they go, they go to many places.
I mean, it's global, completely global.
Yeah,
I mean,
whole Europe, whole Asia, Emirates, everywhere.
And we are as well, I don't know how to say, mother factory, something like that, for China because I mean, at the end, the main production is in Vitoria, and in China is less production as us. Sometimes was in Buenos Aires as well, but the mother factory or where the know-how how to produce is in Vitoria.
Mm-hmm.
Okay.
How important is that know-how?
How important? I mean, I think it's the most important thing. From my point of view, it's the most important thing. So to have people that is already trained is... I mean, because if not, you are loose. You are, I don't know how to say.
Yeah. Vitoria, it's weird that we say that, but Vitoria is one of the best factories from Mercedes, under my point of view. And everything has to do with the know-how of the people. There was a strong bet from our managers to keep the people trained, to keep them within Mercedes-Benz factory in Vitoria, so their growth contributes directly to the growth of the plant. And right now, our technicians are top tier in the industry, and they keep learning, training, adapting to the new problems, and also they are the ones that drive the continuous improvement of our production lines, and that's basic for us. That's what keeps us running, cost efficient, without breakdowns. Well, with breakdowns, but less that could be right for that. That's why for us, training and the know-how of the people is the cornerstone of our production factory.
What is the level of automation in the plant that you're working on?
I mean, we have 3 main shops in our factory. I mean, there is body shop in which make all the metal stuff. Then we have the paint shop in which we paint, and then we have the final assembly in which we put, I mean, the wheels, the engine, everything, the rest of the van. I mean, in body shop it's almost everything is automated. I mean, we have up to 95% more or less of automation. I mean, the only thing that right now we don't have is perhaps the forklifts to unload the trucks, but we are thinking of making that with a van project and that kind of stuff. They are studying how to remove the piece of steel from the trucks to unload. It's the only thing, and perhaps some manual feedings of wood cells.
And the finished part, where
this a minimal part is almost like a big machine from my point of view, a body shop. Then paint shop, that we have many automatic process as well. In this new project, we are going to have even more than before, related mainly with sealing process that we didn't have before. And then we have final assembly.
Yeah, final assembly is the less automated part. Mainly, I think, because it's where the most variation of parts and variants are seen, because as I said before, there's plenty of different options on the van, and many of them in body shop does not affect to the process, and paint shop also not, but they are seen and they are critical in final assembly. One kind of side glass is different from another, then you have to pick it from another way, right? So that's why the manual workers there are more prevalent, and the processes are not that prepared for being automated.
Weird question. On the paint shop, are there colors that are cheaper to produce than others? Why is the difference in price?
Yeah, mainly it depends on the number of
Layers.
layers that you are using. For example, there are colors that are more complicated, or they have to. I mean, at the end in the process, you have the first part of the process is common for all the vans or all the vehicles, which is a kind of to avoid the corrosion. I don't know how to say corrosion is the word. For avoid the corrosion, which is some kind of a special chemical treatment of the surface. That is common for everything, for all the cars, in order to avoid this corrosion and to last many years in a very salty situations, a very complicated situations. And then it depends on what kind of color. There are colors that are more expensive because you have more layers and they have more, or perhaps there are specific colors which are very strange and okay, you want this color, but you are going to pay a little bit more because the most common is always more cheaper. So
every color change needs some procedure, and then the rarest colors are the ones that need more changes, right? So it's not the same to paint, I don't know, we're not experts in paint shop, but 10 white bands, one after another, or having 10 color changes. And
this is why we see so many white vans.
yeah. But it's not the cheaper.
more black,
I think black is the cheaper one. I mean, in cars, unless I don't know, in vans I'm not sure, but in cars it's more expensive white than that.
Okay.
I don't know exactly, but I suppose it's the number of layers.
For those who have not been at automotive plant, can you make us a walkthrough of the process? Are you doing stamping, for example, for the parts? Are you bringing the parts already pre-stamped? How does it work? How do you move the parts?
In body and white, in our factory, we are not making stamping. I mean, if you go in Germany in cars, they still have stamps. Okay. Actually, we are buying these parts to an external supplier, and we receive the parts already stamped. We assemble in body and white at body and white or body shop. The main process is to assemble all these parts to make a whole vehicle without just the steel. I mean, the steel that till the moment has been only steel, but in the new project is going to be as well aluminium, which is a very big issue for us, because till the moment we have been using welding procedures or most of the processes are welding, but now we are going to use mechanical procedures.
Yeah, some joining technologies that are new for us, because as we didn't have aluminium before, I don't know the names in English, but riveting and
clinching,
and screwing,
screwing, a flow drill, which is another kind of.
So as Iván said, the process is like an additive process. It starts with some pieces, then we keep mounting, welding,
pieces and pieces till you have the whole vehicle.
Yeah.
Okay. How does that work specifically? So you are laser welding. Is it mostly riveted? Is it screwed, the parts? And are they done by robots? Is it manual? Is it a mixed process?
The main process for me, I think, is spot welding. Is the main process.
Yes.
I mean,
for our current vehicle,
till the moment is spot welding. That's the main process to join everything. But you have as well arc welding as well in some parts in the current way, in the current process. I mean, then we can speak about the new one, going to be the next vehicle. But till the moment, what we have is mostly is a spot welding process. We have as well gluing as well.
Yes.
Okay. And we have arc welding, laser welding as well, laser cutting. And I don't know if we have more process.
Bolts.
Yeah, there's the other part we have. This is the four 5 main processes that we have. But the question is, with the new project that we are going to work with aluminium, this mix of aluminium and steel, we will need another amount of new process, which are mechanical process to unit, screwing, clinching, riveting.
Where do we see the robots in those processes? What kind of robots?
Industrial robots. I mean, in this case, we are going to use KUKA robots. Till the moment, we have it using AGV robots. And we are joining the standard of cars, the standard we are using currently in cars. And these standard are using KUKA robots.
Yeah, and for all these joining technologies we mentioned, everything is done by robots. There's still some arc welding done by hand, but it's less and less throughout the time. Yeah. So basically, every single, almost every single joining technique we use is done by a robot.
How do you move the cars, the vans from station to station?
Our main system of conveyor is using skids, but we also have as well, I mean, sometimes we use the robot to transport the piece from one station to another station. And we also have the hangers to hold the pieces and to transport from one station to another station.
So it basically depends on the state of production of the car. When it's still small pieces or small group of pieces, then it can be handled by a robot. When it's further into production in body shop, then it's needed those skids that go through the rolling tables. I don't know the name, but and then in final assembly, it's on hangers, because the whole shell of the car is already done and painted. Then and some parts need to be mounted under the vehicle. And that's why we need these hangers and have it on certain high altitude.
You mentioned that you came from traditionally using ABB robots. Now for new vehicles or for the whole factory, it's going to be
KUKA. KUKA, because our standard, which is called Integra, is developed in Germany with our colleagues in the Tech Fabric, which is a center we have in Sindelfingen, in which they develop all the new standards with the KUKA robots and all the technology around the robot, no? So they are developing that with KUKA. So we are just, since 2 years more or less, we are learning this new standard, and we are using this standard for the new lines. And this is involved.
Is it a tough change? I'm thinking also about the technical guys, maintenance.
It's a challenge. I mean,
it's almost like learning a new language. Because it's like, I understand what you want to do, but you do it differently, as I've been doing it for the last 20 years. Not only the programming language is different, also some logic behind it. There are some instructions that they are present on the ABB standard that's not in the KUKA, and different. So it's a change of I would say even culture in robot programming. Also on the mechanics of the robot, on the electrical part of the robot. There's some different solutions every manufacturer has taken. Both are great. I think both.
We are very happy. I mean, till the moment with the ABB robot, it has been a very good experience. But with KUKA, I mean, right now we are making as well in Germany a very good cars as well. So we are sure that we are going to be able as well to work properly with the KUKA robots.
Are you using mobile robots currently?
Mobile robots, we are using mobile robots. The Intralogistics is some AGVs, what we call AGVs. We have several kinds of AGVs with different suppliers. And we have a very interesting in final assembly.
There was a project called MOLOG, Montage and Logistics. The idea was to withdraw all these big containers of the last consume points, right, for the van, and then they did something that for me it's amazing. It's a just in sequence management of the production. That means that there are some car sets done where there's some I don't know how to say it.
Trolleys.
Yeah, there are some trolleys.
Trolleys that you add to the vehicle.
That are
For each
filled with the specific parts for each vehicle. Then they are sequenced, and then an AGV brings it to the consumption point. So it's not only that you have to plan ahead what you have on the line, you have to coordinate yourself in the logistics parts, and then an AGV has to bring it on time, and then go back to for the next ones. And for me, it's very interesting. It was a great job done by the colleagues from logistics and final assembly, because not only it brought some simplicity to the lines, it's also cleaner, leaner on the human part, right? It's less
And more safe
harsh.
as well, because we reduce a lot the forklift traffic that we have inside, moving all the. At the end, we have removed all that traffic, and we avoid a lot of many accidents we had in the past.
Yeah, so the implementation of these AGVs had great impact in these areas, not only on sequence, but also a positive impact. I mean, not only in sequence, but in safety also, and the people, I don't know how to say, but conditions.
Yeah, the ergonomic is I think is more clear and it's easier to add to the. I mean, to add to the piece, because the piece you need to mount is in your trolley that is close to the van. So at the end, you don't have to move. This is moving at the same time. So it's the space you need to reach the piece is closer. So at the end, it's easier as well.
How do you coordinate all the processes and logistics inside the factory? So how do you know when something starts, something finishes, when to go from this to this? Do you have your own software that is coordinating everything?
Yeah, we have some. We have a system, and we call upper systems or management systems, where every single vehicle is located and followed. Okay, you're here. Then it's done differently throughout the production. Some are done in some. I don't know how to say this. These squares. Some tags on the skids, or through tracking of the production number, and that's how we know where a car is from the start to the end of the production. That's where every PLC, every robot checks. What do I have? Okay, I have this variant, then I produce this. Or when will this variant come to here? It's like 5 cars. In 5 cars, it comes to this station. Then I can do the sequence.
You're responsible for implementing new production cells, new robotic setups. What are your biggest KPIs? What are your biggest goals, objectives? What is the most important?
I mean, it depends on when you're designing a robot cell. I mean, we are not responsible of the design of the robot cell. We are responsible of the standard of the technologies that you are going to use, the robot technology, responsibility. But from a point of view of the organization, the KPI most important thing I think is the time cycle in order to reach, and the quality. Both of them. I mean, and perhaps as well the availability of the, which is related with the standard, because at the end, when we decide to install, or when we decide that something is going to be a standard, because we are sure that its endurance is going to be enough, and that's we decide this is going to be our standard. So our main KPIs are time cycle and quality. And of course, as well, the safety of the something. It's not a KPI, but this is something that is always very. I mean, the safety is the most important.
So the first, that it's not even a step, because otherwise there's no station, is the safety of the people, and the environment safety. Then, as Iván said, quality is the most important one. We don't want to rework our vehicles. We want to produce in quality, and that's the main focus, to produce in quality. And then when we make sure that we produce in quality, we have to make sure it's on cycle time and also availability.
Productivity. Yeah.
What do you think are the biggest challenges in safety?
Just a moment. And the other thing that is very important as well, okay, I mean, perhaps now we are starting and you have started a new project, but after having the new project already working, every time you have to make a modification of the line, or you have to change some process in the line. The other thing which is very important is the speed to integrate that. I mean, you always have what we call down production in August, for example. No? You have 4 weeks, and you have to be very, I mean, you have to be, after this week, you have to start. You don't have to start at 100%, but in 2 weeks, you have to be producing with quality. And so what is a challenge as well is the time you have to integrate something and to make that without any kind of failure. That is the other, it's a KPI as well.
Yeah.
I mean, it's the KPI of an integration, which is very important for us as well. So that is the reason, because we have a robot cell before to understand very well how it's going to work in order to be ready to start with the production without any kind of doubt.
Yeah. So as we have to be ready and to hit on the first time, we cannot allow ourselves to miss and to lose production. Then we have to test everything outside of the production line before implementing it on the production line.
What does that mean? How do you test new technologies?
So every time we have to integrate something that is new, that is completely different. We have our labs in the several shops, what we call aula lab, which is training lab, something like that, no, in English. In these areas, we have outside, out of production, we have robot cells or another process as well, in which we prove everything we need before installing the line to be sure that we know or we have or we get all we need for this new process. So we are sure, proving that we have to develop something. Till the moment was developing in the case of the standard programmation, because we have our own standard developed by us. But in the future, for example, with Integra, we have Integra robot cell standard in which we are learning and we are proving that in order to understand this new technology that we are going to use then in the line. So the time you need to integrate in the line is just for that, not for training. For training you have outside, or for the proof you have outside in the labs.
Mm-hmm. Yeah, for example, one example was a pneumatic manipulator that we had to change the concept and so, because there were some changes on the product, and our experience tell us that there may be some problems, not with the equipment, but also with the people getting adjusted to it. That's why we built it on this laboratory factory, and we brought the manual hand workers, and then they advised what to change, how to move it better, how to make it smoother, so we wouldn't lose any production on the moment we started back with the production. This is the mentality of being ready before starting and being trained, and this focus on not losing production when we do this kind of modifications on the line.
What would you say are the bigger stoppers or the bigger no-nos for a new supplier, the most common that you see?
You mean for us when we
choose a new supplier?
Okay.
What are the biggest no-nos that stop you, that you see more commonly?
Right now, for example, is a lack of knowledge about Integra standard. What we need really now is the new standard, which is the standard cars. But I think it's a challenge as well, because this is a standard that is till the moment is being used in Germany mainly, but also I think in USA and South Africa as well. So that's a problem for our suppliers, because they have to get that knowledge. And I think it's not easy. This is our main problem with the suppliers. With the suppliers, I mean, speaking about the robot programming, speaking about the PLC programming, all the automatic environment. I mean, this is the main challenge that we have now. But we are trying to solve it, because they are some of them, of the current suppliers that they know all standard, are now involving as well in the new lines with the suppliers that they already know are standard. But that is our main challenge right now, I think, to get people with enough knowledge about Integra standard, which is the cars standard.
This podcast is brought to you by Synaos, the all-in-one intralogistics platform, orchestrating material flows with mobile robots, forklifts, and people to overcome cost pressures and skilled worker shortages. Visit synaos.com to learn more.
When implementing new products, components, robots, do you normally work through integrators, or do you work direct with manufacturers?
With integrators.
Yeah.
Okay.
I mean,
That's why it's very important for us to have some local or known integrators that know our standards, our way of working, our needs also, and that we are used to them to work with them. One no you asked before, maybe when some integrator doesn't have their own technicians, so they're high rotation maybe, so that may it's not 1-to-1 ratio, but it may bring you some discoordination, some lack of knowledge on your own standard, right? So it may be difficult for us to work with them, or at least more difficult than it would be with someone that is used to it.
Do you also approve the components that integrators are using in the solutions they're implementing?
I mean, till now, yeah. But from now that we are using a standard from cars, which is Integra, this is approved in Germany. Okay? So the component that we are using now for the new lines that we are building with the integrators is a portfolio which is released in Germany, in our test fabric. Okay?
Yeah.
So all the robots are released. I mean, because, for example, Google has many different robots, but we have a specific robots which are released in Integra. But with it's the same with all kind of equipment. I mean, with spot welding timers, with gluing controls. The ones we are using are released in Germany, in our tech fabric, responsible for the standard.
At any case, our goal in engineering is to work very tightly with maintenance and production, and because they are the ones that they're going to maintain and to use the facilities, right? So what's very important for maintenance is to have the less amount of different spare parts. So it's no use for us to have 7, 8, 9, 10 different suppliers for the same thing, because then you go there, you have to change something. Oh.
Yeah. The amount of spare parts is crazy. So at the end, you have to we have to choose this one. In this case, we are using the standard Integra, which sometimes we have several options as well inside the standard. But normally we try to choose one of them in order to avoid the very big amount of spare parts. And of course, as well, the standard is almost, 95% of the equipment, because there is a small part of the equipment that it depends on each factory. So we have a little bit possibilities as well to add some equipment that we specifically need, but there is a reason and exactly whatever we need, and we have the possibility as well to go outside the standard and develop new things. For example, in this project we are developing right now the laser cutting. We are going to make welding with laser, but in this case this is in standard Integra. But we need as well, not for this vehicle, for the commercial one, we need to cut the windows in the side of the van, and this technology is not developed in Integra standard. So we have install a robot cell with a laser through, but we to try to develop all the modules we need to cut the windows of the van.
So in a short way, what is Integra? What does it consist of?
Integra is a standard of hardware and software and programming of all the automatic stations, mainly in body shop, but also in final assembly. This Integra is from PLC to robot to the robot field. I mean, all the equipment, all that kind of stuff.
Like one colleague from us says, it's like a Lego box. The idea behind it is to have everything on the standard that's already proven to work together, and you don't have to develop internally in each of the plants every single communication, every single technology, So we are giving a list of already proven working technologies, working materials, and that's very interesting because it's easier on paper. It's easier to plan and to develop something. Also, as I said before, for the spare parts, and so you have options, but you don't have to develop anything, and that's what Integra intends to make our jobs easier.
And other thing as well is the prices of the different components, because I mean, at the end, from Germany, they assure that all Mercedes is going to buy, I don't know how many robots, how many timers, so the price is going to be much cheaper. So, for example, the price of KUKA for us is very cheap because we buy many robots. I mean, it has sense. So it's the same with the rest of the equipment. If you are able to buy or to say, okay, to boss, whatever, whoever, we are going to buy you, I don't know how many timers that you're going to buy, a very good price as well.
And also know-how, because the know-how can be shared directly between every single plant. We are with our central teams also that give support to the plants. So it's very positive, I think.
And if you have a problem as well, this problem normally is going to be common for everybody. So at the end,
the solution
is going to be common solution for everybody. So I think it has many advantages.
Going back into logistics, intralogistics, mobile robots, what challenges have you faced when integrating vehicles from different vendors? Is this happening? Are you integrating products from different vendors?
Okay, right now we are working with different AGV suppliers. So I think that philosophy we would like to keep on in the future. I mean, it's not like industrial robot that we are working just with suppliers like KUKA or DB some time ago. In the future, from my point of view, we would like to keep on working with severals to have a system that is over all the system and can make they work together. That is, I think, this is our goal in the future. I mean, not to be just with one AGV supplier. We would like to work with several ones, and the way I think is to have a system that is able to make a mix without any kind of problem.
Right now we're working with ABB,
Kefnon, I think is the other one that we're working with.
And in some factories in Germany, it's with Siemens
as well, and I don't know right now more than that, but probably we are working with more of that. I mean,
how do manual operations interact with automated processes on the shop floor? Are you currently, for example, using the collaborative solutions from KUKA? It's only industrial robots?
Well, it depends also on the shop. On body shop, there's not many examples of direct collaboration. It's more feeding the station with parts, and then the robot picks up and processes it. On final assembly, though, we have some cases where we have universal robots, and we do some priming and some gluing activation with those robots on the glasses of the van, and then they are mounted later on the process. And this is the most successful, I think, collaborative robot use on our factory.
It's up to 8 robots.
8 robots.
And then we have an example as well in body and white, but it's just it's not, I mean, it's working, it's a robot as well working alone without they picking some pieces and make some stud welding, that kind of stuff. But the main example is in final assembly with these 8 robots.
Yeah. Okay. There's one important thing regarding collaborative robots is that some process to be able to be integrated with collaborative robots need to be designed for that.
Before.
What we have found is that it's very difficult to adapt a process that's been engineered to be done either only manual or either with industrial robots, to easy adapted to be done with cobots or collaborative
It's because
robots.
of the capabilities of cobots?
It's for plenty of things. One is for the concept of the what are you doing with that? Because one important thing, it's very obvious, but why are you doing this automation, right? What's your goal? Is your goal to reduce the harsh conditions of ergonomics on a manual work? Is it for availability? For which purposes? What is the goal of your automation? And we found that it's very difficult for us to find something that improves really the job being done with collaborative robots and not with industrial robots. I don't know if I'm clear with that. Maybe if you design directly your line with having cobots in mind, then your processes can be adapted to it, to them. But also what's very important for us, as I said, the quality and the safety of the people, but then it comes the cycle time and the availability, right?
Yeah.
We are producing on free shifts, 23 hours a day. So we have to make sure that our facilities are robust, reliable.
The endurance of the
Endurance.
endurance is I think is the most important thing in order to avoid any kind of stop, and that is very hard to make with. I think with the cobots, it was a boom at the beginning some years ago. We thought that perhaps we could have many possibilities, but at the end it wasn't so many. But I think that probably, I don't know, in the future we are going to perhaps mix in the cobots with AI. I don't know. We can have another chance of try to, but not so many possibilities, but some possibilities as well to integrate in more situations. I don't know. It's something. It's my something by heart. I don't know exactly, but I think that could be mixing the cobots with AI.
What do you think are the biggest areas of opportunity for automating new processes at Mercedes?
At Mercedes,
Well, everywhere where there's an ergonomics challenging process, for example, it's the first one that we try to automate, trying to improve the conditions of the manual workers would be one of them. Also, where you need repeatability of the process, applications.
I mean, final assembly at the end, from my point of view, is the part in which you have more possibilities to integrate new automations. But the question is, you have to design the vehicle thinking of robots. Mm-hmm. I mean, because for example, in the body shop process, when you think of the metal sheets that you are going to use, you are thinking of a robot. You are thinking that you're going to use a spot welding gun, you have to a fixture, you have something you have to access. You are thinking of robots. But in the final assembly, you are not thinking of robots. Perhaps, I don't know, perhaps in the future, if we think, we think the vehicle from the point of view of a robot, I don't know how to say, that this robot is going to be involved in the process of manufacturing. That is good, because at the end, the process that we have is what Tony has said, is the process you have in automated in final assembly are glass assembly, the panoramic roof, that very, is easy to automate it. But other process that you have with the kind of pieces you are handling is very complicated. But if you think that pieces in a way that the robot is going to be the one who is going to hold, or the process you are thinking of robot, probably you could automate it more.
Should we design thinking on robots, or should we make robots more like humans?
Well, it's very interesting. Yeah,
it's a mix.
Yeah.
I think it's
why
a
not?
mix.
Why not? Yeah,
mix. I know. Perhaps now the humanoids. I don't know how to say in English. Humanoid. Humanoid robots in the future could be a solution to make. One is to change the product. Another one is to close the robot to a human. Perhaps. Yeah, could be.
Why not?
I don't know.
Yeah. You raise the barriers that an industrial robot brings you, or the challenges, right? This static bolted to the ground, but then if it's moving with you, then it opens a whole new sea of possibilities, right?
Unescapable.
Are there any trials or tests that we can talk of?
Not in our plant.
Our plan, no, I don't know in Germany, perhaps.
Yeah, there's
I think
a collaboration.
Yeah, I think so, probably. But it's something that we don't know, to be honest, we don't know. Probably, yeah. We suppose that, yeah.
It's on the very early stages right now, with the same with the cobots, it has to be robust, reliable to be in a plant like ours, right?
Yeah.
It's very nice, or it's amazing to see one of these new humanoid robots picking parcels and bring it, right? But I need you to do it for plenty of time and with an availability and cycle time of whatever. So this will, for me, this will be the threshold where we can say, yes, they are going to be present on the industry or not. But that's for our industry, because we are producing and we keep producing. Maybe for other kind of industries, these robots are easier to implement.
Yeah.
You mentioned at the beginning the importance of experience of the team at Mercedes. Many people say that robots are stealing jobs. Do you think this is the case?
We don't think so. From our point of view, well, Tony can speak as well about that. I think that most of the process in which we are integrating robot are processes in which I think the ergonomic is not, or the safety for the person, or it's not the environment. I mean, for example, a robot welding, spot welding, making welding in body white. I mean, at the end, the smoke, the whatever, I think is not healthy. So it's much better to be this kind of robot, this kind of process in which the repetitivity, I mean, at the end, psychologically, something psychological, I think it's not a very good situation as well. So I think it's a better situation for the human. It's from my point of view. And of course, as well, you are improving the kind of, I mean, at the end, we need workers as well to maintain the robot, to program the robots, not only the robots, also all the process, and this is you need people with more training, with more qualification. So I think it's an improvement from my point of view.
Yeah, the required profile changes, but you still need PLC programmers, roboters, electric technicians. So it may be not be one-on-one. You need also engineers. So it's like transforming your workforce to a more specialized workforce.
Skillful, I don't know, something more qualified people. I think it's primary. I think we are not destroying. I mean, even now when we are removing some workers from the line because we are putting robots, because you are automatizing process, in our case, we are not firing these people. These people is relocated in other places in which they're going to be better than before. No? We are not firing people, installing robot and firing people. That's not our goal right now. But of course, in the future, the people that we will need is going to be people more qualified. That is the reason.
What do you see as the biggest trends that we will see in robotics and automation the coming years?
I think that with AI is going to be something with that. I don't know what exactly, but I think that when they all together, it's going to be a mix that is going to be very powerful.
I think the same way that phones evolved to smartphones, I think the robots are going to evolve to smart robots, and they are going to assess themselves, saying, I have this failure, these levels of, I don't know, oil is low, the temperature, this is something not working. And I think the industry will evolve to have a more, I don't know how to say it, but more direct KPIs from the robot, not post-processing the data, but live data from the robots.
with the big data.
With
that
big
kind of
data,
stuff, Michelle. Well, we are making some use cases with that. I think that is very interesting. Now with the IoT, or with Internet of Things, we are in the next project. We are going to have almost all the equipment connected and sending data. And we will like to process in real time this data in order to take decisions, that kind of stuff. With the robot as well, it's related with the maintenance of the robot, with to preventive, to work in advance, to avoid problems in advance. But I think a step ahead is about the kind of intelligent robot. I don't know what to say. With the AI, I think it's going to be very. I mean, with big data altogether, it's going to be a kind of very gap. I don't know how to say it.
And if we wander even further in time, for me, it's pretty clear that these humanoid robots will be present in somehow on the industry, either bringing the parts to the line, moving little boxes of parts. I don't know, but I don't think they are going to be welding like in the movies, right? The robot with a manual. They're not big. They're not going to be one-on-one workers, but they're definitely doing some stuff in our production lines, I guess.
What would you say to someone that is getting into automation, specifically in automotive, to a new engineer?
That is a challenge world. I think it's very interesting. That is every day is something new. Every day is something that you have to discover. I mean, I think it's one of the most interesting things that I ever work with. I think it's because you are dealing with different technologies, different. I think you are in the state of the art. I think it's very, very interesting.
Yeah, and always, it's like a cliche, but always keep learning, because there's plenty of solutions that someone may have think about that you could never imagine, right? And be humble and learn from everything and everyone, even from the oldest hand worker that's been in the same machine for 40 or 30 years. They know a lot. They know how things could go better, and to keep your eyes open and your ears ready to get every single input that you can. And maybe there are some people that they are not experts, but they know things, right? And
the experience
it's great. Yeah.
What would you say to current suppliers and future suppliers? How can we be the perfect supplier for Mercedes?
Knowing Integra. So from my point of view right now, for sure. I mean, it's our main goal just now, and then to try to understand our KPIs or necessities, which is because of what we are expecting from them is that. I mean, the end, very good integration in a short time with endurance, with that kind of stuff. I mean, at the end, what we are waiting for a line for a builder is, I mean, we are going to manufacture vehicles with a high added value, and we need that our suppliers have a very big added value as well. So that's what we need, and that means that we need quality, and we need speed, and we need endurance in the integration.
You mentioned quality, but what does it mean?
I mean, I want a robot that lasts forever, for example.
Okay.
I mean, it's impossible, but clothes last forever. I mean, that is quality for me. The same like we are going to supply to my customers. We are going to supply a vehicle that is going to last forever. No, but probably, but we are expecting that from our suppliers as well.
Yeah. Also, flexibility is expected from our suppliers, because in our world, where everything seemed very monolithic and very stable, for the last 5, 6, 7 years, everything's been changing so much, and we have to adapt not only into what our customers need, but also what the regulation says, and then every single month there's something coming. We have to change this. We have to take this in account. So we also need this kind of flexibility because our customer demands it from us, and we have to work with people that's flexible, and also being trustworthy with what they can do, what they cannot do, and how they're going to be honest as well. We need, as we said, we've been here. This factory has been here for many years. We plan on being here many others. I want to retire here, so minimum 30 more years. Every single thing I plan with a provider has to be durable, trustworthy, and it's okay if we could talk if there's some concept that's not doable or something that's any difficulties that come, but we have to develop this relation based on trust with them, because they're going to be in our house doing our course and so helping us, so they have to be trustworthy.
Thank you very much for being here.
You're welcome.
And hope to see you back soon and maybe visit your factory one day.
Yeah, you're invited. Thank you so much for inviting us.
Thanks a lot.
Thank you very much.
Thanks for listening to Intralogistics Insiders. Stay tuned for more insights and subscribe on Apple Podcasts, Spotify, or your favorite platform.